So basically 8085 the chapter first chapter, in that you have few questions that you have to do properly. One is your evolution of microprocessor. Okay, evolution of microprocessor, the 3 marks or 4 marks question is asked. Now in this case you have to write how many bits that microprocessor is, that is number of bits the microprocessor. You have to give the examples, and then you have to give the characteristics. If you can write the year, you it's okay, means you can write it. The generation number and the bits number should be proper. Otherwise, first generation la 8 bit lila, second generation la 4 bit lila, it will not work. Okay, so 4 bit microprocessor, basically the first generation microprocessors were, and those were 4040 Intel's Kiva 4004. Mainly they were used in the calculator. Okay, calculators मध्ये these first generation microprocessors were used. Then the second generation microprocessors, the number of bits were 8, 8080, 8085. The Zilog's are Z80. त्याच्यानंतर basically Motorola's are 6800. All these are the examples of your 8-bit microprocessors. 8008, 8080, all these were Intel's microprocessor. Basically the concept of RAM, ROM, IO ports, okay, all those things were IO ports. Okay, those all things were there. Clock. Okay, so those were in this second generation of the microprocessor. So those concepts were introduced. Then the third generation,
मला एक क्वेश्चन आहे.
हा
क्लॉक म्हणजे लिटरल घड्याळ का?
घड्याळ नाही. So clock is nothing but a signal, square waveचा signal जो असतो, that is called as the clock.
Oh, okay.
This particular signal is called as the clock.
Okay.
Then 16-bit microprocessor, if you see, it is nothing but 8086, 80186, 80286, 8088, Z8000, Motorola 68, 000. All these were 16-bit microprocessor. Naturally, the memory capacity was increased, as well as the execution speed was increased, as well as basically multi-processing environment साठी these microprocessors were used. 4-bit microprocessor, 32-bit microprocessors आहेत. So 80386, 486, okay, 80486. Then you have Motorola's M68020. All these are 32-bit microprocessor. The moment you say it is a 32-bit, that means it is number of data bits, not address. So basically higher level languages were introduced. Okay. So you can write the program in the higher level languages because of these microprocessors. Then the 5th generation microprocessor had come, and then 64-bit microprocessor, Pentium. Then you have 80586. Okay, all these are the examples of 64-bit. So different operating systems were used in these microprocessor, as well as graphics, multimedia techniques was introduced. So if you see, generation number जसा वाढत जातो, number of bits double होत जातात. 4 पासून चालू करायचं, डबल करायचं 8, 8 चा डबल 16, 16 चा डबल 32, 32 चा डबल 64. So this question comes for 3 to 4 marks. Then 8085 say features. Okay, what are the features of 8085? So basically when you write the features, number of bits of the microprocessor you should write first. So it is nothing but 8-bit microprocessor. That means it can process 8 bits data. Okay. Then it has 16 bits address. Okay. So 16-bit address hai. So 2 raised to 16 combinations are possible. So 2 raised to 16 म्हणजे काय? The 2 raised to 6 into 2 raised to 6 into 2 raised to 10. Okay. So that is nothing but 2 raised to 6 is nothing but 64 kilobyte of memory. right? And 2 raised to 10 is called as kilo. So 64 kilobyte of memory is available with 8085. Then the clock frequency is up to 5 to 6 megahertz पर्यंत clock frequency. Clock frequency, just now I show you the signal. This particular signal is called as the clock, and its frequency is around 5 to 6 megahertz पर्यंत 8085 ला असते. Then the main thing is nothing but the lower 8 bit of the address are multiplex with 8 bit data. So data is denoted by D symbol, right? And address is denoted by A symbol. So A15 to A0 असे तुमचे 16 addresses आहेत. Okay? So ह्यातले lower 8 bit कुठले असणार आहेत? तर A0 to A7. These will be lower 8 bit and A8 to A15 will be higher 8 bit. So these lower 8 bit addresses are multiplexed with the data. So data is denoted by D, that is D7 to D0. So the address and the data which are multiplexed are denoted by AD7 to AD0. Okay. Then it uses IO mapped IO scheme. Okay. For the memory, it uses IO mapped IO scheme. Then plus 5 volt of signal it needs, voltage. It has 40 pin dual inline package, so DIP package, and it has 74 instructions. So these are the main features of your 8085. Got it?
Oh,
Now this is nothing but your second question, which they usually ask. Then the third question which they can ask about is nothing but the interrupt. Okay. What is an interrupt? Interrupt is a signal which is given by either hardware or software, right? Hardware or software to the microprocessor so that the microprocessor suspends its normal operation and gives service to the signal. Okay, it gives the service to the signal. So basically, if you want to show by the diagram, the microprocessor is executing its main program. The interrupt signal appears. Microprocessor will stop what it is executing, and it will execute the interrupt service routine. It gives the service to the signal, okay, by executing the interrupt service routine. And once the interrupt service routine is over, it comes back to the main program. There are two types of interrupts. One is called as the hardware interrupt, and second one is called as the software interrupt. So software interrupt is due to the programs, and hardware interrupt is due to the hardware circuitry. There are 5 types of interrupts. Hardware interrupt: RST 7.5, RST 6.5, RST 5.5, and INTR. Okay. So trap is also called as RST 4.5. Then the software interrupt is denoted by RSTN, where N varies from 0 to 7. Okay, where N will vary from 0 to 7. Okay, so trap has the highest priority, then RST 7.5. See, basically, software interrupt always has the higher priority than the hardware interrupt. In hardware interrupts, the priority is given, maximum priority is given to the trap. Okay, so the trap has the highest priority, then RST 7.5, then RST 6.5, then RST 5.5, and then INTR. So according to the decreasing order of the priorities, the hardware interrupts will be given by this. Then the interrupts are divided into maskable and non-maskable interrupts. The maskable interrupts are those interrupts which can be avoided or kept pending, while non-maskable interrupts will not be kept pending. Okay, the service has to be given to them. So RST 4.5, that is trap, is nothing but your non-maskable interrupt. And all software interrupts are also non-maskable, RSTN. Maskable interrupts are RST 7.5, RST 6.5, RST 5.5. Okay, RST 7.5, 6.5, and 5.5. Okay, all these are RST, RST, RST. You have to write first. Huh? I have written it in the short form. Okay. Then the interrupts are also divided into vectored and non-vectored interrupts. What are the vectored interrupts? The interrupt service routine is at fixed location. When these interrupts occur, that time the control will be transferred to a fixed location. Then it is called as the vectored interrupt. While in non-vectored interrupt, the interrupt will not be, the interrupt service routine will not be at the fixed location. Okay. So that is called as your non-vectored interrupt. So vectored interrupt are RST 7.5, RST, all RST interrupts, okay, 6.5, RST 5.5, and trap. All these are vectored interrupts, as well as all software interrupts are also vectored interrupts. That is RST N wale suda software interrupt means RST 0 to RST 7. Non-vectored is interrupt request, that is interrupt INTR. Okay, then you have to write the vector addresses. Now, whenever you write the vector addresses, either you mug it up, the vector addresses, or you have to multiply the number by 8. Okay, and then convert it into hexadecimal value. So if it is trap, that means RST 4.5. Right? Trap is also called as RST 4.5. So 4.5 into 8 you have to do. That is a decimal number. You have to convert it into hexadecimal. Once you convert it, it becomes 0024. Then if you see RST 5.5, it is 002C. 002C. Then if you see RST 6.5, it is nothing but 0034. Okay. And if you now see what is RST 7.5, RST 7.5, it is nothing but 003C. So these vector addresses are very important because they can ask you what are the vector addresses, what are the vector interrupts, and what are the vector addresses. Okay. So just see, these are your hardware interrupts vector addresses. If it is RST 0, the address will be 0000. Okay. The vector address will be 0000. Then if it is RST 1, the vector address will be 0008. If it is RST 2, then it is 0010. Okay. RST 3, it is nothing but 0018. If it is RST 4, that is nothing but 0020. RST 5, it is nothing but 0028. RST 6, 0030. It's very easy to remember if you don't know how to convert it. Okay, and it is RST 7 will be 0038. See 8, 0, 8, 10, 18, 20, 28, 30, 38. Okay, so these are the vectored addresses of your interrupts, software interrupts. Okay, so this question or this topic you have to do it properly. Then the next question which usually asked is nothing but about the flag register. So flag register is called as the status register, which is an 8-bit register. Okay, which has 5 flags. It has only 5 flags, which gives the status of the answer. So what is the structure of the flag register that you should learn by heart? Sign, 0, don't care, auxiliary, don't care, parity, don't care, carry. Okay. So sign flag, 0 flag, auxiliary carry flag, parity flag, and carry flag. These are the basically 5 flags are there. Okay. So usually 3 bits are unused, 8-bit flag, and 5 flags are there. So fill in the blanks also they can ask. Or suppose the flag register value is so and so, interpret its meaning. So before interpreting, you should know sign flag is 1. That is, that bit will be 1. So it will be said as set or reset, right? So if this bit is 1, that means sign flag is set. If this bit is 0, that means the sign flag is reset. So sign flag 1 कधी असतं? When the MSB of answer is 1. 0 flag 1 कधी असतं? If the answer is 0. Okay, totally 0 पाहिजे, means all the 8 bits should be 0, 0, 0, 0. Okay, then the 0 flag will be 1. Otherwise, it will be 0. If it is a non-zero answer, Z flag will be 0. Auxiliary carry, if there is a carry from lower nibble, means lower 4 bits. Nibble means 4 bits to higher nibble. Then it is nothing but auxiliary carry is 1. Okay. Then parity flag is 1. So auxiliary carry always has the lower nibble to higher nibble प्रमाणे carry असेल तर auxiliary carry will be 1. Parity flag will be 1 if even parity. Even parity means number of ones in the answer are even. Okay, 8-bit answer मध्ये the number of ones तुम्ही count केले. If it is even, then it is called as even parity. Even parity असेल तर parity flag 1 असतो. For odd parity, parity flag is 0. Carry flag is 1 if carry at MSB position. Okay. If there is a carry at MSB position, then it is nothing but the carry flag will be 1. Otherwise, it will be 0. इथपर्यंत कळलंय का?
हो.
Okay, so suppose if they ask you to interpret, if the flag register is 54, it interpret its meaning. So 54 is hexadecimal, you have to convert it into binary. So binary, hexadecimal to binary conversion, you should do it properly. If you cannot do this, then your answers will be wrong. For conversion, you use the which 8421 code, okay, and then convert it. So 54 is given by this, right? So how will you write 0, 1, 0, 1, 0, 1, 0, 0. Now you have to interpret its meaning. Sign flag काय आहे? तर 0, right? That means MSB of the answer is 0. That means it is positive number. जर sign flag 1 असेल, then it is called as the negative number. Okay, MSB of the answer 1 असणार आहे. 0 flag 1 आहे, so answer is 0. Auxiliary carry 1 आहे, so there is carry from lower nibble to higher nibble. Parity 1 आहे, so there is even parity in the answer. And carry is 0 in this case, so there is no carry at MSB position. So this is the interpretation of the flag register. Okay, so this is nothing but your flag registers. This is about your flag registers. Then other registers also they can ask you. So A register is called as the accumulator. Barobar, how many bits register it is, that you have to mention. It is 8-bit register, and then you have to explain its use, right? So basically the answer is stored in the accumulator. Barobar, then one operand is in the accumulator, correct? Usually for arithmetic or logical operations. Then for interrupt masking, we use the accumulator contains, or serial input output साठी we use the accumulator contains. Okay, all these things you can write about the accumulator. Then all the general purpose register B, C, D, E, H and L. These are called as the general purpose registers. They can store 8-bit number individually. But if they form a pair, that is BC together, DE together, and HL together can form a pair. And if a pair is formed, they can store the 16-bit number which can be either the address or it can be the data. Then special function register, stack pointer. Stack pointer is a 16-bit register which holds the address of the top of the stack, of the top of the stack. Stack is a memory where you can store the register contents temporarily, right? So if you are storing the register pair contents temporarily, this top of the stack above which you can store them, right? So this address, for example, if it is 7500, then stack pointer should contain 7500. Okay. Then you can initialize it by LXISP instruction. Okay. By the push instruction, push RP instruction, the stack pointer will be decremented by 2, and with pop RP instruction, the stack pointer will be incremented by 2. Okay. So this is what you'll have to explain when it is a stack pointer is asked. Then the program counter, how many bits? 16 bits register. Okay. It always points to the next executable instructions address. Okay. So that is the use of the program counter. Then you have the temporary register and instruction register. So temporary register is nothing but your 8-bit register which is not used, okay, not used or not accessible, okay, by the user. Okay, it is accessible only for the microprocessor. Okay, it is not accessible to the user during, it is a part of ALU, that is arithmetic logic unit. So during arithmetic or logical operations, the contents will be stored in the temporary register. Then you have the instruction register. It is an 8-bit register, okay, which holds the first byte of instruction. Okay, so that is the use of it, and it sends that byte to the instruction decoder. The instruction decoder decodes it, okay, and then executes the instruction. Kiva then asks the control and signal, the control timing and control signal to generate the signal. So these are the, this is about the registers, what they can ask you. Then the next important diagrams are there in the chapter 1. The most important diagrams are nothing but microcomputer and the explanation of the microcomputer parts. Okay, so basically microcomputer, that is a big diagram which you have to draw. Okay, so 8085 block diagram, pin diagram, microcomputer. Okay, so this is your microcomputer block diagram. So remember the computer's main blocks. What? Like the CPU पाहिजे, input devices, output devices, and memory. So CPU, right? Then you have the input device as keyboard, output device as display, and memory is ROM as well as RAM. Okay.
मला क्वेश्चन आहे मेमरी मध्ये असं आय थिंक सेकंड पेजवर दिला असं पीएम आणि डीएम असं म्हणजे काहीतरी सॉरी परमनंट मेमरी आणि काहीतरी असं वाला मेमरी काहीतरी होतं तसं
Permanent memory ती ROM असते.
हा
That value you cannot change, ROM ची. Okay. So data memory is nothing but your RAM, read write memory. जे आता आहे तेवढंच कर तू. बाकीचे ते जे नंतरचे आहेत, whatever are your difficulties that we will solve later on. आता जे तुला परीक्षेला, आता सोमवारी परीक्षेला आहे, that you do it first.
ओके
So keyboard and display are your input and output devices. Keyboard interface and display interface are the interfacing ICs. Why they are required? Because the input output devices are slower than your CPU. Okay. So if it is in order to match the speed with the CPU of the input output devices, we use keyboard interface for keyboard and display interface for display. MPU and CPU is your control, central processing unit, which controls whole action and processes the data. It requires a clock signal that is given by the clock. ROM has the programs in it which can be read only. The instructions are fetched from that memory. In that memory you cannot write anything. That is, that memory you cannot alter. Okay. RAM is a random access memory. It is a read-write memory where you can store the data. Okay. So these are the main blocks which you have to do. Then power supply कडून प्रत्येक unitला the power is going, right? So it gives the power to every unit of the microcomputer. Then you have to draw right hand side la the data bus. The data bus, the data will carry the data. The data will be sent or received by the microprocessor. So you have to draw the bidirectional arrow here. From keyboard, the data will go to the microprocessor. So this direction arrow. From ROM, only the instructions will be fetched, right? So again, you have the unidirectional arrow. RAM, bidirectional arrow, right? Because read-write memory. On the left-hand side, you have the addresses, right? Address bus. So address bus carries the address, right? So the address is sent by the microprocessor to all the units of the microcomputer, right? So keyboard interface la, ROM la, RAM la, आणि display interface. See, if all the addresses are going to everyone and everyone tries to use that address, it will be a chaos. Therefore, the address decoder is used, which will decode the address. And for a particular combination of addresses, only one block will be selected. Okay. So address decoder will decode the addresses and send the chip select signal to the either display interface, keyboard interface, ROM, RAM. Okay. So for example, 00002003FFF has a address असेल. So for example, keyboard साठी असेल. So that for those addresses, decoder will send the chip select signal for the keyboard interface. Okay, for example, 6000 to 7FFF. It is a RAM area. So in that case, if that address combination appears, then the address decoder will select the RAM. That is the main use of it. So this is the microcomputer block diagram, which you'll have to draw and explain. Usually it comes for the 4 marks, draw as well as explain. Then comes your 8085 block diagram. In the block diagram, you have to remember the blocks, okay, of 8085. So what are the blocks which you have to remember? The first one is registers block. Second one is ALU. Third one is interrupt block. Fourth one is serial input output block. And fifth one is your timing and control section. So register names, you know, B, C, D, E, H, L, stack pointer and program counter. Okay. Then you have the incremental and decremental latch. So that will increment and decrement the addresses. So addresses, you know, 16-bit address hai A0 to A15. Out of that, AD0 to AD7, that is lower 8-bit of the address is multiplexed with the data. So here if you see, it is a data address buffer, which gives address AD0 to AD7. Data is bidirectional, therefore this arrow is bidirectional. Then if it is going to increment the higher, the higher 8-bit of the addresses are A8 to A15. So address buffer ला जातं आणि तिकडनं A8 to A15, right? Then if you see instruction register, instruction decoder, the first byte of the instruction goes to the instruction register. From there, it goes to the instruction decoder, and then the instruction decoder ने काय decode केलंय त्याच्यावरून timing and control signals will be generated. So this is your another block, right? IR, instruction decoder, and timing and control. Control signals are bidirectional. Serial input output मध्ये SID, SOD pin, that is serially input करतो data as well as output करतो. Therefore, this is a bidirectional. Interrupt control, right now we saw these are 5 hardware interrupts: TRAP, RST 7.5, RST 6.5, RST 5.5, INTR. And there is one interrupt acknowledge signal, So that signal goes out from the microprocessor to the external devices once the interrupt is acknowledged. Therefore, you have the bidirectional arrow here. Okay. So 1, 2, 3, 4 blocks are over. Then you have to draw the ALU block. ALU is arithmetic logic unit. So basically you will need one operand in the accumulator. So accumulator is associated with it. Temporary register is associated with it and the flag register is associated. Now temporary register is non-accessible. So unidirectional ही data bus आहे त्याला unidirectional असणार आहे. Accumulator bidirectional. From accumulator the arrow should go to the ALU also. Bidirectional arrow. Then flag register is accessible, therefore bidirectional arrow, and then flip-flop. Okay, the flag register is connected to the ALU unit. So these two arrows you have to remember extra. Okay, so these are the things. So first draw the blocks and then remember the arrow. Okay, then the next diagram is nothing but about your pin diagram of 8085. So when you draw the pin diagram of 8085, basically pin diagram, if you draw
डायग्राम दिसत नाही मॅम मला फक्त तुमचं फोल्डरचं फाईल दिसतं.
pin diagram, if you draw, then it is a 40 pin IC ahead, right? So 40 pin IC, the pins are equidistant of each other and exactly opposite of each other. There is a notch over here. Okay. Notch left hand side, you must show pin number 1 and anti-clockwise you should write the pin numbers. Okay. So that is how you write the pin numbers. 8085 is nothing but the IC number. Okay. Now, if you see in this case, the last, see, pin number 40 and pin number 20, exactly opposite the pin side, there you give the supply voltage, which is a plus 5 volt is given to pin number 40 and ground, that is 0 volt is given to the pin number 20. Okay, so these are two input pins. Any 3 pin they can ask for explanation. So pin function, you must do it properly because in the final exam also any 3 pins are asked for explanation. Okay, so whether it is input pin, whether it is output pin, and what is the function of it, that you should see. So pin number 40 is plus VCC, that is plus 5 volt is given to through this pin. So input pin I. VSS is pin number 20, that is nothing but 0 volt is given through this pin. Now it has a 16-bit address. So A0 to A15 is the address, and out of that the lower 8-bit address are multiplexed with the data. So it is AD0 to AD7, right? So AD0 to AD7 exactly varti ahe ground cha, right? That is 0 volt. Bidirectional pins are the lower 8-bit of the address is sent on these pins, or the 8-bit data will be sent or received on these pins. A8 to A15, higher 8-bit of the address is sent on these pins. Okay. So this U is over. Okay. Now these multiplex pins, the advantage kai hai, the number of pins will be reduced. And whether it is address or data will be decided by ALE pin, that is address latch enable. If address latch enable is 1, then AD0 to AD7 represent A0 to A7. Otherwise, it represents D0 to D7. Then त्याच्यावरती exactly interrupt block आहे. So trap, according to the priorities, the interrupts are there. Trap, RST 7.5, RST 6.5, RST 5.5, INTR, and interrupt acknowledge bar is the output pin. So trap, while writing the trap, magashi apan interrupt चा केलं, that thing you have to write. Input pin, highest priority, hardware interrupt, non-maskable interrupt. It is a vector interrupt. So control will be transferred to 0024 location. Similarly, for RST 7.5, second highest priority interrupt, maskable interrupt, the control will be transferred to 003C, therefore it is vectored interrupt. Similarly, for RST 6.5, 5.5, you have to write. INTR full form is interrupt request. All these are input pins. This is the lowest priority hardware interrupt. It is a non-vectored interrupt. INTA bar, interrupt acknowledged. It is an output pin. ज्याच्यावर बार असतो ते लो असेल तर ते काम होतं, right? If that signal is low, then that particular work will be done. So interrupt will be acknowledged by the microprocessor when INTA bar is low. Okay. So interrupt is acknowledged by the microprocessor and it sends a low signal on INTA bar. Then SOD, SID, serial output data, serial input data. Output data आहे म्हणजे output pin पाहिजे. SID is nothing but input pin. So SOD, right? So basically, if you remember the RIM-SIM instruction, through the RIM-SIM instruction, SIM instruction, the D7th bit of the accumulator will be sent on SOD. Through RIM instruction, the signal on SID will affect the D7th bit of the accumulator. So these are your, then if you see X1, X2 are the crystal inputs. Crystal is a device which gives the clock signal to the microprocessor. So these are the input pins. 5 to 6 megahertz clock frequency aste crystal chi. Okay. Now exactly half frequency will be sent on the clock out signal. Okay, so 2.5 to 3 megahertz signal is sent on this. This is an output pin clock out, right? It is used to synchronize the whole operation of the microprocessor with the external device. Reset in bar, there should be a bar here. Okay, when this pin is low, the microprocessor resets. All the registers will be, contains will become 0, 0. Once the microprocessor resets, it sends the reset out signal on this pin. Hold and hold acknowledge. Okay. So hold is nothing but a signal which is given by the external circuitry to the microprocessor so that it wants to access the memory directly for DMA operation, DMA. Okay, DMA, for DMA operation, the external devices send the signal to the microprocessor, okay, and the microprocessor acknowledges that signal by giving the high signal on HLDA. So once HLDA is high, okay, so that is nothing but the DMA साठी address and data is released by the microprocessor. Okay, so DMA word should come when you are explaining hold and hold acknowledge. Then ready signal is an input signal. Okay, so ready signal is an input signal. So the external devices like printer have the slower speed. So when they are ready to send the data or accept the data, they send the ready signal to the microprocessor and then microprocessor will send the data or accept the data from them. Then if you see IOM bar, this is also a multiplex pin, input output memory bar. This signal is output pin. When this signal is high, the IO, that is input output devices, are used for reading and writing operation. When this is low, memory is used for reading and writing operation. S1, S0 are called as the status signal. Depending upon the combinations of S1 and S0, read operation, write operation, opcode fetch operation, interrupt acknowledge operation will be done. So that table is given in the textbook. S1, IOM bar, S1, S0. Okay. So that table you must remember while explaining this. Read bar, write bar. Okay. These are output signals. When these are low, the reading and writing will be done in the memory or in the input or output devices. ALE, address latch enable. This is the output pin. When this pin is high, it selects address on the AD0 to AD7. And when it is low, it selects D0 to D7. Okay. So that is nothing but your ALE signal. It is never tri-stated. So this is the explanation as well as the pin diagram. Okay. Pin diagram can be asked, but always any 3 pin they ask you for explanation. Then there is another diagram which is called as the generic microprocessor diagram. But I personally feel that diagram is too, I mean, there are too many arrows and everything. Okay. So it is thoda sa tumhara to difficult jato. So if you know the 8085 चा block diagram, same diagram, similar diagram you have. See, IR, instruction register, instruction decoder, and timing and control. So this part is same as 8085. Then in the register block, you have HL and program counter and stack pointer. Now the interrupt wala block is given to the timing and control section only here. So interrupt control where only INTR is the interrupt. Then they have shown the clock wala block, which gives the clock crystal chip inputs and the clock signal is going out and it is given to the timing and control. Then plus 5 volt and ground are the supply voltages. Then data bus D0 to D7, address bus A0 to A15, 16 bit. And then this is your ALU section, accumulator and temporary register. And the flag register is now inside ALU, they have shown. Complementer and shifter are used for addition and subtraction. Two's complement method ne you do the subtraction. Right? Adder is used
ते
for
परत हे स्विच झालं आता जस्ट
uh,
परत ते स्विच झालं मला फक्त फोल्डर दिसतंय परत. मला 2 सेकंदात दिसत होतं तिथं गेलं परत.
generic microprocessor दिसलंच नाही तुला.
नाही मला दिसलं ते मध्ये असं हे झालं असं टॅब आउट झालं माहित नाही का.
So this is nothing but your shifter is used for your multiplication or division. Complementer is used for your subtraction. So this is the generic microprocessor का diagram. नुसता ALU चा आला तर नुसतं हे काढायचंय. Accumulator, temporary register, adder, flag register हा वाला पार्ट काढायचंय. And explain करायचंय. Accumulator कशासाठी वापरतात? One operand is stored in the accumulator. Answer is stored in the accumulator during arithmetic and logical operation. Temporary register stores the data temporarily during arithmetic and logical operations. Flag register gives the status of the answer. Adder is used for addition. Complementer and shifter are used for the subtraction and multiplication or division. Right there?
हो.
So this is nothing but these are the diagrams which you have to draw. So most of the questions will be
ते परत फोल्डर दिसतं.
हो आता मी काय ते हे नाही करत.
ओके.
The most of the questions will be I have covered right now. जर स्टॅक रिलेटेड असतील तर त्या इन्स्ट्रक्शन मध्ये जे स्टॅक रिलेटेड असतात ते सगळे असतात म्हणजे पुश पॉप इन्स्ट्रक्शन. ओके, those we can do it. Then this is another diagram which is in the second chapter, instruction cycle. So here you have to draw the clock signal. Okay, so this square wave is nothing but your clock signal. Okay, one complete square wave is nothing but T state. Okay, so T1, T2, T3. Then number of T state मिळून one machine cycle दाखवायची. So they have shown 2 machine cycles and 1 instruction cycle, number of machine cycle मिळून. So usually this diagram carries 1.5 marks and 1.5 marks for the explanation. So T state is nothing but the sub operation of the instruction which is done in one clock cycle is called as the T state. Then machine cycle, the part of the operation. Okay, see, instructions are divided into sub operations, right? So the time required for completion of the sub operation is called as the machine cycle. For example, memory read आहे, memory write आहे, opcode fetch आहे. All these are nothing but your machine cycle. So one machine cycle consists of number of T steps. One instruction cycle, the time required for the execution of one complete instruction. पूर्ण instruction execute व्हायला जेवढा वेळ लागतो, that is called as the instruction cycle. So it consists of number of machine cycles. Okay, so that thing you have to remember. So these are the diagrams. Now, how the reading and writing is done in 8085, or it is memory mapped IO and IO mapped IO. What is the difference? Okay. So in the memory mapped IO and IO mapped IO, what is the difference? So basically in the memory mapped IO, the certain addresses are reserved for the memory and certain addresses are reserved for the input output devices. For example, if you have the total memory 0000 to in 8085 you have these addresses, right? So out of that, for example, for memory 0000 to 9000, एवढं जर तुमचं किंवा 8FFF is the addresses which will be reserved for the memory, and 9000 to FFFF will be for your input output devices. So if the address is 4000, then it is definitely for the memory, and if the address is 8000, it is definitely for the input output devices. So here you don't need separate signal, okay? Because you exactly know कि हाँ address है means it is for the memory, or हाँ address है it is for the input output devices. So no separate signal is required. The memory will be less because total memory तुमच्याकडे 0000 to FFFF पर्यंत असू शकते. But since the addresses are reserved for the memory, then the memory will be less. And always there will be a 16-bit address, okay, for memory or input output device. In IO mapped IO, any address can be for the memory or for the IO devices. So for example, 4000 हा address आहे, तो memory साठी सुद्धा असू शकतो किंवा IO devices साठी सुद्धा असू शकतो. Then how will you come to know कि it is for the memory or for the input output devices? You need a separate signal called as IOM bar. If IOM bar is high, then your signal is for the input output devices. And bar म्हणजे memory operation असणार आहे. So if IOM bar is low, then it is for the memory. You can consume all memory, right? You can have all the memory, right? 00 to FFFF एवढे सगळे addresses तुम्ही memory साठी वापरू शकता. And it requires 8-bit address for IO devices, for IO operation. Okay, 16-bit address for the memory operation. Okay, so साधारण हे questions असतात in the first chapter. Second chapter मध्ये all instructions you should know. Second chapter मध्ये you should know which instruction affect which flag. Okay, which flags are not affected by which instruction. Then how many bytes instruction it is, and addressing mode. Okay, so addressing mode first I will tell you, that is also in the first chapter. Okay, it is nothing but the way the data is accepted by the instruction. The instruction मध्ये data is specified, right? From where are you going to take the data? So that is nothing but addressing mode. So there are 5 addressing mode: direct addressing mode, register addressing mode, register indirect addressing mode, immediate addressing mode, and then you have the implicit addressing mode. Okay, direct addressing mode मध्ये 16-bit address is mentioned in the instruction. For example, LDA instruction, LDA, and then you have to mention the 64-bit address, that is 4-digit address. So LDA 4500. The data is in the address and that address is mentioned in the instruction. Then it is direct addressing mode: LDA, STA, LHLD, SHLD. These are 3 bytes instruction. Register addressing mode मध्ये the data is in the register and register name is mentioned in the instruction. For example, move A comma B, right? So the data is in B register, you are moving it into the A register. So it is 1 byte instruction. Then indirect addressing mode, data is in the address, but that address is in the register pair. It is not directly specified in the instruction. So all M wale instruction, move A comma M, or LDAX RP, STAX RP, these are your 1 byte instruction, and these are your indirect addressing mode wale instruction. The data to be operated upon is mentioned in the instruction. Okay, whether it is a 1 byte or 2 byte data. So I wale instruction, for example, MVI A, 05, right? So that 05 is mentioned in the instruction. So these are 2 or 3 byte instructions. LXIH, okay, that is also I wala sagya instruction. Implicit or implied mode of addressing, nothing is specified in the instruction. Usually the data is in the accumulator, usually logical instructions astat. For example, RRC, RLC, all these are 1 byte instructions astat. Okay, so this is also an important topic. Always you will get one question on this. Now I'll quickly revise all the instructions. Okay, the instructions which I will revise. First one is your data transfer group of instruction. You can make a Excel file. Okay, in that you have to write the name, the instruction, general instruction syntax, what it does, example, how many bytes, flags which are affected, and addressing mode. Okay, data transfer instruction affects, no flags are affected by this. Okay, now in this case, if you see, the first instruction is move instruction, RD, RS. The data from the source register will be copied into the destination, right? So your destination register can be A, B, C, D, E, H, or L, or it can be M also. Okay, if it is M, then addressing mode will be indirect. If it is any register, it will be direct addressing mode. Then source register can also be again A, B, C, D, E, H, or L, or it can be M. Okay. So basically, you can say, for example, move A, comma B. So how will you give the example move A, comma B? So B मध्ये समजा 05 असेल, तर A मध्ये काय येईल? 05 येईल, कॉपी होईल. Okay, that you have to explain. 1 byte instruction आहे, right? If register names are A, B, C, D, E, H, L, then it will be register addressing. M असेल तर तो indirect addressing. Then MVI 8-bit number. So when the 8-bit number has to be copied into the register, again the register can be A, B, C, D, E, H, L, or it can be MVI M also. I आहे म्हणजे immediate addressing mode. जेव्हा 8-bit number लिहिलेला असतो instruction मध्ये, त्या 2 byte instructions असतात. 16-bit number लिहिला असेल तर त्यात 3 byte असतात. And if nothing is mentioned, then they are 1 byte instruction. So this is a 2 byte instruction. So this 8-bit number, for example, MVI A, 05. So 05 will be copied into A. Then LXI RP. The register pairs are B, C, D, E, H, L, or it can be SP also in this case. Okay. Register pair contains 16-bit number. So 16-bit number is necessary to be written here. This 16-bit number will be stored in the register pair. Okay. So basically, register pair लिहिताना फक्त higher register लिहायचा, LXI B, LXI D, LXI H, or LXI SP. And then 4-digit number तुम्हाला लिहायचा आहे. So LXI H 7600. The meaning is 76 will go in H, 00 will go in L. Then comes your next instruction, which is nothing but LDA 16-bit address. The contents of the address will be copied into A. So if I say LDA 4500, 4500 will not be copied. Contents of 4500, address से contents से 8-bit असतात नेहमी. For example, 67 असेल, then accumulator contents will be 67. Okay, that is how you will have to explain it. So this is a 3 byte instruction. So LDA exactly opposite is STA, 16-bit address. So accumulator contents will be copied into 16-bit address. So STA 4500 if I write, then first I will have to take the value in A. 05 जर असेल, तर after execution 4500 मध्ये तुमचे 05 येतात. Okay, that is nothing but SPA. Then if you have LHLD, 16-bit address, the contents of the address will be copied into L and the next address say contents will be copied into H. Okay. So again take the example. LHLD for example 4500 घेतलं. तर 4500 मध्ये काय व्हॅल्यू आहे ती L मध्ये जाईल आणि 4501 मधली व्हॅल्यू ही H मध्ये जाईल. Okay, so just write that particular, understand the thing and then write. Okay, suppose 4550. The contents of 4550 are, for example, 23 and contents of 4551 consecutive addresses घ्यायचे 48. Then your L contents will become 23 and H contents will become 48. Okay, so this is how you'll have to explain. Lower म्हणजे ज्या ऍड्रेस मेन्शन केलाय त्याचे L मध्ये जातात, नेक्स्ट ते H मध्ये. If you say SHLD, okay, then H the contents will be copied into this and L the contents will be copied into the next consecutive address. So here you will have to take the values in L and H, right? So L मध्ये suppose 25 आहे आणि H मध्ये समजा A2 आहे, right? So 4550 will become 25, okay, and 4551 will become A2. Okay, so these are your SHLD and LHLD. All these four instructions have the direct addressing mode. Then you have LDAXRP. Exactly opposite is SPAXRP. When the address is in the register pair, register pairs can be BC or DE only in this case. कारण M हा HL साठी असतो, right? त्यामुळे contents of the address, if the address is in HL pair, then the contents will be moved from the memory to accumulator. So if you say, for example, LDAXB, okay? So BC मध्ये जो address आहे, BC मध्ये समजा 4500 आहे आणि 4500 चे contents हे 34 असतील, तर accumulator contents will become 34. That is the meaning of LDAX. STAXB, if you say, that time if the contents of BC are this and the accumulator contents are, for example, I will take now different number 05, then the contents of 4500 will become 05. Okay, so that is how you will have to explain. त्याच्यानंतर if you see, exchange is the instruction which exchanges the HL pair contents with the DE. H चे E मध्ये जाणार, D मध्ये जाणार आणि L चे E मध्ये and vice versa. Okay, so H and D will be exchanged, L and E will be exchanged. So you have to take the numbers in HL and DE and after exchange you have to say what is the value. Clear?
हो.
Okay, so all these are your data transfer group of instruction 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, hardly there are 10 to 13 instructions. कारण जेव्हा तो move एक RD, S असू M असू शकतं किंवा RD, RS असू शकतं. तर त्यामुळे ते 3 instructions we can. So हे 13 instructions नीट आल्या पाहिजे if you want to write the programs.
ठीक आहे.
Arithmetic instructions. In this case, one operand usually is in the accumulator, other operand will be in the register or in the memory. Okay, answer will be stored usually in the accumulator. Now add R or M, right? Then ADI 8-bit number. So what they do, the accumulator मध्ये कोणाचे contents add होणार आहेत? If you say add R, it will be register चे contents, it will be memory चे contents, right? And the answer will be stored in the accumulator. If it is 8-bit number, then accumulator contents will be added with the 8-bit number and the answer will be stored in the accumulator. Okay, basically addition will be the hexadecimal, binary addition ने करायचे. Okay, त्यामुळे 5 plus 5 10 नसणार आहे, 0A ही व्हॅल्यू असणार आहे. Okay, so that you should remember. All flags are affected. Most of the instruction affect all the flags. Then if it is ADC, R or M or ACI 8-bit number, so what it does, the contents of the accumulator will be added with carry. So whenever you want to add the bigger numbers, okay, for example, instead of 8-bit numbers, if you want to add 16-bit number, 24 bits number, 3 byte number, okay, तेव्हा तुम्हाला प्रिव्हियस कॉलम मधनं कॅरी येणार आहे. So तो कॅरी सुद्धा ऍड करावा लागतो. There you are using this, right? So plus there will be the previous carry. Okay, so that is nothing but the difference between add and ADC. Okay, then you have the DAD instruction, DAD RP. The basic full form is double addition. The contents of the HL will be added with the register pair. Register pair can be BC, DE, HL or SP. Okay, and then the answer will be in the HL register. Only carry flag is affected with this DAD instruction. Okay, add मध्ये accumulator मध्ये answer असतं 8-bit addition असतं, DAD ला 16-bit addition असतं. Then sub instruction, the contents of the register or the memory will be subtracted from the accumulator. The answer will be stored in the accumulator. If it is SBB, R or M, the contents of the register or memory or 8-bit number will be subtracted from the accumulator with carry. Okay, with carry म्हणजे कसं असणार आहे, सपोज ऍडिशनचं जर तुम्ही म्हटलं तर सपोज दिस इज द नंबर and suppose 06 and suppose 10. These are the two numbers which I am adding. So F0 and 10 add केल्यानंतर what you get is the answer 0 0. F plus 1 is 10, right? So there will be a carry over here. Okay, there will be a carry at this particular position. So this carry has to be added. So there you will be using ADC or ACI instruction. तसं जेव्हा सबट्रॅक्शन असेल तर कॅरी सबट्रॅक्ट करायचा असेल, then you will use the SBB or SBI instruction. The answer will be in the accumulator. Okay, the subtraction is done by the 2's complement method and always the carry is complemented after subtraction. जो carry असेल तो complement करतो. Okay, microprocessor. Okay, so whenever you are giving the example, at that time you'll have to take the example, show the 2's complement method of subtraction. Okay, and the carry has to be complemented. So if it is SBB or SBI instruction, that has to be subtracted with carry. Okay, so these are your subtraction instruction. Then most important which you need are nothing but INR register. Exactly opposite is DCR register. Okay, then you have INX. X जेव्हा जेव्हा असेल तेव्हा register pair असते, DCX register pair. INR instruction will increment the register contents by 1. So 8-bit number 1 ने increment होणार, the answer will be stored in that respective register. Okay, decrement ला 1 ने decrement होणार. Okay, register pair, if it is INX RP, so register pair contents will be incremented by 1 or decremented by 1. So 16-bit number will be incremented or decremented. In this case, here INR or DCR, in this case, the carry is not affected. All flags are affected except carry. Okay, except carry. INX or DCX instruction will affect no flags. No flags are affected by INX and DCX instruction. And the last instruction is DAA, decimally adjust accumulator. This is the only instruction which uses auxiliary carry flag. No other instruction uses. After addition, basically it is used to convert the number into decimal. Okay, answer जेव्हा तुम्हाला convert करायचं असतं decimal मध्ये, there DAA is used. If after addition, this instruction is used after addition only. Okay, not after subtraction, after addition only. So if suppose, if you say, if after addition lower nibble is greater than the 9 असेल, then it adds 06 in the answer. हायर निबल ग्रेटर दॅन 9 असेल or carry is generated असेल. Okay, here lower nibble greater than 9 or auxiliary carry generated असेल. Then it adds 60 in the answer. Microprocessor adds itself. We don't add. Lower nibble and higher nibble both are greater than 9 or auxiliary carry or carry is set. It adds 66 in the answer. Okay. For example, आता 05 असेल. 05 plus 05. So this is 05 plus 05. Your answer is 00001010. The lower nibble is greater than 9. So microprocessor will add 06 in the answer. So you get the answer as 00010000. That is the answer will be 10. So 5 plus 5 चा answer त्याने 10 केलं. Okay. So all the three conditions you will have to show. So in this case, the DAD instruction affects only carry. INX DCX doesn't affect any flag, and INR DCR affect all the flags except carry. Rest of the instructions affects all the flags. Then logical instructions, these are very important. कारण 3 किंवा 4 मार्काचा question येतो. If accumulator contents are so and so, register contents are so and so, what are the contents of the accumulator after the execution of this instruction? So ANA, register or memory, ANDing operation है. ANDing operation like both the bits are 1, then only the output is 1. ORA, register or memory. ORI, 8-bit number. Then XRA, register or memory. XRI, 8-bit number. All flags are affected. Again, one operand has to be in the accumulator. Answer will be stored in the accumulator. Then CMA will complement the accumulator. Okay. So these 4 operations first you should know. If suppose accumulator contents are 78 and suppose D register contents are F2, then after ANAD, what are the contents? Okay. So you have to show it this way. 5 मार्काचा एकदा एका वर्षी प्रोग्रामच्या ऐवजी हा क्वेश्चन होता. So how important these questions are, you should see. Okay. So 1111 0010. Now ANDing करता है. So when both the bits are 1, then only output will be 1. So 01 will be 0111. कळत आहे का? Actually I have done this. Okay. So this, the answer in the accumulator will be 70. This is how you will have to show. Okay. इथपर्यंत सगळं दाखवायचं. ANDing instruction affect all the flags. Carry is reset of course, but auxiliary carry is set in the ANDing operation. Okay. ANDing operation ला जरी auxiliary carry नसला तरी auxiliary carry set होतो. OR operation जर असेल ORAD, in this case if one of the bit is 1, output will be 1. So 1 1 1 1, right? So because one of the bit is 1, this will be 1, then 0 1 0. So the answer in the accumulator will be FA. Correct? XOR operation, when both the bits are different, then only the output will be 1. So this is 1, same, 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 different, same, different, same, right? So 8 2. So hexadecimal to binary and binary to hexadecimal आलं नाही. Sorry, 8 8. Then your answer will be wrong. CMA instruction will complement the accumulator. मग 78 आहे तर 1 चा 0 करणार आणि 0 चा 1 करणार. So it will be 1 0 0 0 0 1 1 1. So the answer will be 87 in this case of the accumulator. CMA affects, no flags are affected by the CMA instruction. Okay, no flags are affected by CMA instruction. Then you have the CMPR or M and CPI 8-bit number. So this instruction compares the contents of the accumulator with register or memory or 8-bit number. Okay, if both of them are same, okay, then the 0 flag will be set because it actually subtracts the number. Okay, पण तो subtract करून answer store नाही करत. So 0 flag is set. accumulator contains doesn't change in the compare instruction. Subtraction ला subtraction चा answer हे accumulator मध्ये राहतं. So it changes the answer. Okay. Then if accumulator is less than your register or memory, then the carry flag will be set. And if it is greater, then your carry and zero flag both will be preset. All flags are affected, but you have to check carry and zero for equality and inequality. Then you have the simple instruction STC exact and then CMC. STC will set the carry. Carry flag will become 1 in this case. Complement carry. So carry जर 1 असेल तर carry काय होणार 0. Carry 0 असेल तर carry काय होणार 1 होणार. Okay, that is nothing but your complement carry. Only carry flag is affected by STC and CMC. Implicit addressing mode आहे. RRC exactly opposite is RLC. RAR exactly opposite is RAL. Rotate accumulator right, rotate accumulator left, rotate accumulator right through carry, rotate accumulator left through carry. Okay, so accumulator चे जर content समजा 0 1 0 0 0 0 0 1 आहे. Okay, so in this case if you see RRC ला काय होईल? RRC ला D0 bit will affect the carry as well as it will affect the D7. Rotate करणार आहे. That means every bit will be shifted towards right position. So this bit will go here, this bit will go here, this bit will go, this bit will go here, go here, go here. Okay. Now this bit will go here as well as it will affect the carry also. Okay. So the accumulator contains will be nothing but now 1 0 1 0 0 0 0 0. Okay, that is your RRC. त्याच्यानंतर RLC instruction. RLC instruction काय करतं? Exactly opposite. Means every bit will be shifted towards its left position. Okay. So for example, suppose accumulate. So RLC मध्ये काय होणार आहे? कोण बाहेर पडणार? The D7 bit will go to D0 as well as it will affect the carry. So suppose my number is 0 1 0 0 0 0 0 1. So every bit is now shifted towards left. So this 0 will come out, right? So instead of that, it will be replaced by 1 0 0 0 0 0 1, and that 0 will come to the D0 bit. So 82 will be the answer. Okay, only carry flag is affected by RRC and RLC. Implicit addressing mode आहे. Okay, त्याच्यानंतर RRC is used to divide the number by 2, RLC to multiply the number by 2. Now RAR आणि RAL मध्ये काय होतं? RAR मध्ये D0 bit will come out, it will affect the carry, and whatever was previous carry will go to D7. Okay, the difference between this is that, right? D0 goes here to carry as well as D7. Here D0 goes to carry and carry goes to the D7 bit. So in this case, suppose the number is 0 1 0 0 0 0 0 1, right? And if your carry flag is nothing but 1 असेल किंवा 0 असेल for example. So with the RAR काय होईल? So every bit will be shifted towards left, right. This bit will come to carry, and whatever is the carry will go here. Okay, so it will be 0 0 1 0 0 0 0 0, and your carry will be now 1. Got it? So that is the difference between RAR and RAL, RRC. Same thing with the RAL. RAL काय करणार? D7th bit will go to carry and carry will go to the D0 bit. Okay, so that is the difference between RAL and RLC. All these are implicit addressing mode. Only carry flag is affected 1 2 आणि ह्या 4 instructions. Okay, no flags are affected by CMA. Okay, then you have the branching instruction, jump and 16-bit address, unconditional branching instruction आहे. The control will be transferred to the 16-bit address by this. Conditional branching, jump if carry, jump if no carry. त्याच्यानंतर again you have to mention the 16-bit address in front of it. Okay. त्याच्यानंतर you have jump if 0, jump if not 0. If the condition is true, it will branch out. So when I say jump if carry, if the carry flag is set, then it goes to the 16-bit address. Okay, all these are 3-byte instructions. Okay, त्याच्यानंतर jump if parity even, jump if parity odd, त्याच्यानंतर jump if minus, and jump if positive. The meaning of it is if the carry flag is 1, the control will be transferred to the 16-bit address. If carry flag is 0, control will be transferred to the 16-bit address. 0 flag 1 असेल किंवा आन्सर 0 असेल तर ब्रांचिंग आउट होईल. नसेल 0 फ्लॅग 1 नसेल तर ब्रांचिंग आउट होईल. पॅरिटी इवन म्हणजे पॅरिटी फ्लॅग 1 असेल तर ब्रांचिंग आउट. जेपीओ मीन्स पॅरिटी फ्लॅग 0 असेल तर. जम्प इफ मायनस मीन्स साइन फ्लॅग 1 असेल तर, साइन फ्लॅग 0 असेल तर. Same thing with the call. Call is used for the subroutine साठी. So call 16-bit address, and instead of J, if you write C, it will be call असणार, right? Call if carry, call if no carry. Then you have the return instruction. The control will be transferred back to the main program after the execution of the subroutine. And here instead of JC and JNC, you can write return if carry. No 16-bit address is required. Return if no carry, return if 0, return if not 0, and so on. Okay. So these are your branching instructions. PCHL is also called as the branching instruction. PCHL मध्ये HL चे contents are copied into program counter. So program counter always has the next executable instruction चा address. So HL जर 7500 असेल तर PCHL ने program counter will become 7500 and the next instruction at 7500 will be executed. SPHL मध्ये काय होणार आहे? HL चे contents copy होणार stack pointer मध्ये. So if HL is 7500, stack pointer will become 750. SPHL is stack related instruction. Okay. Then branching instruction मध्ये RSTN, that is also interrupt wali instruction, is also considered as a branching instruction because the control is transferred to the vectored address, right? Therefore, त्याच्यानंतर stack related push RP and pop RP, exactly opposite. Whenever you want to store the contents of the register pair on the stack, we use push RP, and whenever you want to restore it, we use the pop RP. Push RP instruction will decrement the stack pointer by 2, while pop RP instruction will increment the stack pointer by 2. Okay. Then pop register pair मध्ये BC, DE, HL, and then you can use PSW. Processor status word is the addition of, the pair of A register and the flag register. Okay. So XTHL is the instruction which will exchange the top of the stack with HL. Top of the stack वरच्या 2 values ज्या आहेत त्या HL, H आणि L शी exchange होतात. Then interrupt related instructions आहेत तुमच्या rim and sim and rim instruction. Set interrupt mask, read interrupt mask. Accumulator चे contents will be used to mask the interrupt. So D7 bit is called as the SOD, SDE, don't use. Then the flip-flop, RST 7.5 flip-flop हे करण्यासाठी mask set enable, then to mask 7.5, to mask 6.5, to mask 5.5. Okay, mask 5.5. So these are the 8 bits of the accumulator. Okay, so accumulator चा हा D7th bit झाला. D7, D6, D5 bit is not used. D4 bit is used for the internal hay. D4, D3 bit, D2 bit, D1 bit, and D0 bit. Okay. So in order to mask the interrupt, the bit should be 1. Okay, D0, D2, D1, D2, 1 असेल तर interrupt mask होणार आहे corresponding, provided D3, that is mask set enable, is 1. Whenever you want to send the data on SOD pin, SDE should be 1, right? D6 bit should be 1. Then only D7 bit with which value will be sent on the SOD pin. RIM instruction ला same आहे, फक्त D7 bit is called as the SID. Then interrupt 7.5 pending आहे का, 6.5 pending आहे का, आणि 5.5 pending आहे का. Interrupt enable आहे. Then you have the 7.5 mask केलंय का, 6.5 mask केलंय का, 5.5 mask केलंय का. That is given. Okay, that thing will be given by this. So suppose if you have SID 1 and this 1, this 1, this, sorry, 0, this 1, okay, this 1, this 1, this 1, and this 0. The meaning of it is RST 7.5 and 6.5 are masked. RST 5.5 is not masked. Okay, so which is masked? 1 means masked, 0 means not masked. 5.5 and 7.5 are pending. Okay, and SID pin were high voltage आहे. That is the meaning of it. Then you have two more instructions, NOP and halt. Okay, no operation, it doesn't do anything. Halt, it takes the microprocessor into wait state. You have to press the reset key after the halt instruction. Then there are two more interrupt related instruction, EI and DI, right? Enable interrupt and disable interrupt. Interrupt related instructions, stack related instruction, machine related instructions, and input output related instruction come under a machine control group of instructions. In and then 8-bit address, it is similar to your LDA instruction. Out and 8-bit address, it is similar to your STA instruction. Okay, this is called as the port address for input output devices. So if you say the 8-bit address is copied into the next higher order address. Okay, so in 40, if you say the total address is converted into 4040 and the contents of that address will be read or copied into accumulator. LDA च्या similar आहे. So LDA कळलं असेल तर तुम्हाला हे येईल. Okay, similarly out instruction, A ची contents will be copied into the port address. Okay, so basically you can copy it. So A40 चं म्हटलं, so basically 4040 ही address मध्ये convert होईल आणि accumulator मध्ये जी value आहे ती त्या address मध्ये store होईल for out instruction. Okay, so these are all instructions in the instruction set. So please go through it. Program मध्ये basically you have to do lot of practice for the program. Okay, so ते
Okay.
एका दिवसात किंवा 2 दिवसात program